I here to do a quick video on normal lines at the tangent line. So, in essence, what we're doing is on the curve of f of x, we've built a tangent line, and now what we want to do is we want to find that normal line, and that is the perpendicular line that comes to the tangent line. So, perpendicular to the tangent line is what a normal line is. If you've studied some vectors before, you may have a little bit more of an understanding of what the normal line is, but basically it's the perpendicular line. So we have to go back to some algebraic rules and remember, how do we find a perpendicular line or a slope that's perpendicular to our original function? So normal lines, tangent lines. All right, what is a normal line? A normal line, again, is a line that is perpendicular to the tangent line, where the slope is the negative reciprocal of the parallel slope. In other words, our m value in the slope-intercept form is y equals negative 1 over m x plus b. So in essence, what we have here is we've got some function and here, and then if we draw a simple function, and it may go like this, right? And we're here. And what we want to do is we want to find a tangent line at some point. So maybe it's over here in the negative x category. Well, this tangent line might just skip off the function right here. Now, in order for us to find the normal line, we want the perpendicular line, and that will create a 90-degree angle. So we are looking for that normal line that comes in perpendicular degrees with the tangent line. In other words, we need the negative reciprocal of our m value that we find. So in the equation y equals mx plus b, our is given by the first derivative. And what we do is that f prime of c, where c is the given x value, will give us the quantity or the value of the slope. But that's the parallel. That is the tangent line that is running alongside the function here. What we want is the perpendicular line. So what we have to do then is take that value that we found at c and negate it and make the reciprocal. So let's see how we do. Example number 1. Here we go. It says, write the equation of the normal line to the tangent line at x equal negative 3. Here we have a function, x squared plus 2x plus 1. And the first step is to find the first derivative. So, f prime of x is 2x plus 2. Take the 2, we bring it down, still power rule. And then 2, derivative of 2 is 2x is just 2. Derivative of 1 is 0 because it's a constant. Then, we need to substitute the given x that we've gotten from the problem here. And it says that x equal negative 3. So we're going to plug into our derivative the negative 3 plus 2. We get negative 6 plus 2 is negative 4. Well, this would be the m for the tangent line. However, we're not looking for the tangent line. We're looking for the normal. So we have to take the negative reciprocal of the m. And so if it was negative 4, then we want a positive 1 over 4 for our example here. Going along. Step 3, now we have to find the y value. Because in y equals mx plus b, your slope-intercept form, we'll get the m from the first derivative. The y is from the y value, the function, and the x is normally given at some point. Okay? So, what we do is we find f of negative 3, and I hope you can see this, it's green, but f of negative 3 squared plus 2 times negative 3 plus 1. Well, negative 3 squared is 9, and then 2 times negative 3 is negative 6 plus 1. Negative 9 minus 6 is positive 3 plus 1 is 4. So we get 4 as the y value is equal to 1/4 positive. That's the m value. Negative 3 is the x. And we get, once we multiply here, this is negative 3/4. So we add 3/4 to the other side. And 4 we can break up into 16/4. So 16/4 plus 3 is 19/4. And then we're at y equals 1/4 x plus 19/4. And that is your normal line equation to the tangent. All right. Thanks. Hope you had some fun. Enjoyed. Thanks. Have a great night.